Hello, everybody. Good afternoon, good morning for wherever you are, and welcome to this session on VPC. So we're going to talk about networking for the VI admin, and the goal is to show you how you can easily use virtual private clouds in VMware Cloud Foundation. So my name is François Tallet. I'm a product marketing engineer. I'm here with Dimitri Deschmidt, who has the same title as mine and who is going to answer your question live. So let's start. I'll start with high-level agenda. Oops, if I can. Yeah. So first, we're going, of course, to talk about a little bit about what a VPC, a virtual private cloud, is, and we'll see some of the capability that are making VPC easy for the VI admin to consume. We'll have a short demo where you'll see how we can easily deploy an application straight from vCenter thanks to the VPC model. Then the second part of the presentation will be a little bit more technical. We'll explain still at a high level how VPCs work in VCF. Another demo will show you how you configure VPC starting from a fresh VCF 9 install. And we'll have a quick conclusion on the use of VPC and where you should try it at home, basically. So let's start immediately with the virtual private cloud. So what we call a virtual private cloud can be seen as a kind of sandbox, a kind of dedicated environment where the application developer can deploy their virtual machines. I'm going to insist on the application developer because the goal is to make something that is very simple for somebody who is not a networking expert to provide connectivity to their workload. So what we want is that this person can easily create virtual networks that we call subnets in this context via the vCenter UI or via API and attach their virtual machine or their containers to those subnets and provide the appropriate connectivity. So again, the target persona is not a network expert. So we're trying to do as much as we can in the back end so that it's almost plug and play for them. So VPCs will provide automatically the IP address, the subnet, if you want, of those subnets, the IP blocks that they will use. It will configure a default gateway, a DHCP server if you want to. And we'll also see that there is an additional capability that will allow you to basically control the scope, the span of those subnet. What can those virtual machine attached to a subnet reach in the virtual and in the physical infrastructure? So this is because in a VCF environment, of course, we want to instantiate multiple of those virtual private clouds. So how do they communicate with each other? What can they reach? If I connect a virtual machine in my private cloud, how far can it reach? So we want to provide some control for the application developer on this front. And the main option that has been developed by VMware is a vDefend firewall, which is a complete security solution with layer 7 firewall, etc. This is really a tool that is targeted at a security admin. So instead, the VPC model includes a very simple way of restricting the span of a subnet, and it's a kind of t-shirt size option that we're offering to the application developer. And we have 3 t-shirt sizes that I'm going to describe right now: private subnet, private transit gateway subnet, and public subnet. So let's start with a private subnet. So if you attach a virtual machine to a private subnet, so you create a subnet, you're going to basically select one of those 3 t-shirt sizes and say that I attach my virtual machine to a private subnet. In that case, my virtual machine can reach all its peers within the VPC. So local connectivity, that's a given. Even if those subnets are different, they have different IP addresses, there is some implicit routing between those subnets. However, your virtual machine on a private subnet will not be able to reach peers VPCs inside VCF, nor they will be able to access the physical infrastructure. In terms of IP addressing, again, I mentioned earlier on that we want to give everything in an automatic fashion, an automated fashion to the application user. So the subnet will get an IP block, and this IP block is taken from a larger block called a private IP block that is defined on a per VPC basis. So you pretty much choose what block you're going to use here. Here I'm using an RFC 1918 block, but you can put pretty much whatever you want. And when you create a private subnet, you're going to be able to specify the size you want, and automatically a sub-block will be carved out of the private IP block and assigned automatically to your private subnet. So that as a user, I don't have to worry about IP addressing. It comes automatically. And of course, if I'm using DHCP, my virtual machines will also get an IP address automatically without me doing anything. So this private IP block is again on a per VPC basis, meaning that each VPC will have its own private IP block for their private subnets. And because the scope of this block is limited to the VPC itself, you can even reuse the same block between VPCs. So for example, here I've put this 192.168.0.0/16 on two VPCs. This is fine because anyway, those two, the VMs on those private subnet in the two VPCs cannot talk to each other. The way I see it, it's a little bit like your home router, which by the way use the same kind of subnet. You have a local IP block, and nobody can initiate a connection toward your home PC on this block, at least not without some advanced networking option. So same here, those private IP block are local to the VPC and can be duplicated because of that. Now let's talk about the private transit gateway subnet. So hold on to the name. I will explain later why it's called private transit gateway. Just assume that it's a different kind of connectivity option that is offered here for your subnet. So if you attach a virtual machine to a private transit gateway subnet, it will still be able to communicate with peers inside the same VPC, of course. But this time it will also be able to reach other VPCs in the VCF infrastructure. So you have an additional span in terms of connectivity for your virtual machine in that case. However, in the end, you still cannot reach the physical infrastructure, so you're still private to the virtual infrastructure. Well, you're not visible from the outside world, and you cannot reach the outside world. In terms of IP addressing, same as for the private IP block that we were using inside its VPC. This time we have a kind of private transit gateway block that is defined at the level of VCF that is common to all private transit gateway subnets that are defined inside VCF. And well, IP addresses will be assigned from this block. Here too, I put a subnet that is in the RFC 1918. You can again put whatever you want as long as it doesn't conflict with something else. And finally, the public subnet. So as you can guess, it will provide even more connectivity. So if I attach a virtual machine to a public subnet, it will of course be able to connect with peers inside the VPC, between VPCs in VCF, and at last, it will be capable of communicating with the outside world. So this is a very important difference because this time it means that the public subnet and its VM are going to get IP addresses that are public, that are known from the physical infrastructure. So this is still assigned automatically for you. However, you'll see that this block now will have to be defined with some cooperation with the administrator of the physical network, because having this public IP address means that the physical infrastructure is aware that this subnet is inside VCF, and it needs to be capable of forwarding the traffic to those IP addresses in this block toward the VCF infrastructure. And conversely, VCF must be able to attract traffic to this block. So this time you cannot put any IP address. You have to coordinate with the physical infrastructure owner. So this is a summary of all this. Basically, it's all a matter of scope. You see the private subnet is scoped to a VPC, whether it is in terms of reachability or in terms of IP addressing. The private transit gateway subnet is scoped to VCF, again, in terms of reachability and IP addressing. And finally, the public subnet has a global reach, and it needs to have an IP address that is routable. By the way, let me uh, clarify here. When I talk about a public address, this public subnet, it doesn't mean that this IP subnet needs to be internet routable. It just means that it needs to be routable within the physical infrastructure. Okay, so we're going to do a little demo illustrating all those concepts, and hopefully you'll see that it's very simple, and my goal is to encourage you to try this feature because it's very nice, I think, and it allows you to consume networking in a very simple way from vCenter. So suppose that we have a two-tier application. This is really a lab environment, nothing really realistic here. I have a web tier, which must be accessible from the outside world, and an app tier, which is a kind of backend application that is local private to this application. And what I'm going to do from vCenter is create a VPC for this application so that it has its own sandbox, create a subnet for my app VM and attach it to it, create a subnet for the web VM and attach my web VM to it. And finally, we're going to check the kind of connectivity that we're having, assuming that, of course, my web subnet is public and my app subnet is private. So let's start from vCenter. You see that I have my two virtual machines that are already existing but not powered on. I'm going to go into the networking tab. And now in VCF9, you have a section inside my data center networking. I have a whole section on VPC, Virtual Private Cloud. And because no private virtual private cloud has been defined yet, there is a button to add a new VPC that I'm immediately going to click, of course. So adding a VPC is very simple because it's pretty much a matter of giving it a name. I can give any name I want, of course, and defining this private IP block that I've been talking earlier on, which is the block from which we're going to assign IP blocks to the subnet, the private subnet we create inside this VPC. Again, you can put whatever block you want. I just like to keep 192.168 at that level. I click Save, and my virtual private cloud, Francois VPC, has been created. And I even have a little topology view in this section directly in vCenter. You need to be aware of that. We are in vCenter. I'm not using NSX here. Actually, I'm using NSX, but it's vCenter that is a client of NSX here. So now I'm going to create my subnets. So let's click on Create a new subnet. And creating a subnet, that's a network, right? A virtual network is a matter of giving it a name. You have the access mode. I'm going to leave private. And I'm going to ask for a subnet size of 256. So I don't need 256 IP addresses. What it means is that this subnet can handle up to 256 IP addresses. I don't need that much, of course. Behind the scene, it's going to allocate a /24 block. It looks better. So that's why it's just for cosmetic reasons that I put 256. You could use 16 addresses or even less, in fact. And in the advanced setting, I've asked for a DHCP server. This is not mandatory. If I don't have a DHCP server, then I will have to manually select an IP block and put manually an IP address on my virtual machine. But my virtual machine is configured as a DHCP client, so I'm configuring a DHCP server, and this is going to be automatically for me. No other option. I'm clicking next and finish, and my app subnet is created for me. So you see that it got automatically a /24 IP subnet. It's 192.168.0.0. You can see the IP address of the default gateway that was automatically assigned for me, and also the DHCP server that has automatically been assigned or instantiated for me at 0.2. So now I'm going to attach my app VM to this subnet. So that's a pretty usual operation. I'm going to edit the property of the virtual machine, and instead of selecting a DV port group for attaching my network adapter, you see that now we have the option of attaching to a VPC subnet. The DV port group is still available behind the network option. And I simply attach my app to my app subnet, start it, and after a while, it gets an IP address in the app subnet, and it gets a .3, the first available IP address in this block. So now I'm going to repeat this operation from for the web subnet. So I'm creating a new subnet. I name it web subnet. But this time I'm going to make it a public subnet so that my web tier is accessible from the outside world. Again, I'm using 256 for cosmetic reason, and I'm selecting DHCP server. So I'm finishing this configuration. My web subnet is immediately instantiated in the physical, well, in the virtual infrastructure. You can see this in the diagram. And I'm going to also attach my VM, my web VM to this subnet. The subnet got an IP address in 10.1 /16. I've not shown you where this address is coming from here. Just assume that it's been pre-configured, and I'm just focusing on the role of the application developer who doesn't care where this address is coming from, in fact. So let me attach my virtual machine to this. Same operation as before. I'm going to edit the properties and attach WebVM to web subnet. Just again, like I would do to a DV port group. And I'm starting the virtual machine, and you'll see that it will get an IP address in the subnet range. Here we are. So I got this IP address 10.1.1.3. And basically that's it. I have deployed my two-tier application, and now it's a matter of checking whether it works, of course. So I'm going to open a web browser, and I'm going to, oops, I missed something, sorry. Oh yeah, I'm showing the topology. So I'm going to open a web browser and enter the public IP address of my web VM, the 113. And I get an answer from the web server that is running there. And this web server is, so I'm accessing this web server from outside of VCF. So you can see that I have external connectivity. Somehow the traffic from my workstation has been routed to this web VM inside a VPC in VCF automatically. And this web VM is also capable of reaching the app backend server at 192.168.0.3. So on the top of having north-south connectivity to the outside world, I also have east-west connectivity inside my VPC for my app subnet. So those two subnets are routed with each other. So let me try now to reach uh, the app server automatically. Sorry, directly. I mean, and well, I'm showing you. It's not a very interesting example, of course, but the connection in failing. Basically, what I'm trying to show you here is that the app subnet is isolated from the outside world, and this app VM is not reachable from the outside world. And it's not just because this 192.168 subnet is local to the VPC. There are access lists, in fact, on the VPC that prevents. I mean, even if the app VM was trying to reach the outside world, its traffic would be dropped actively by the VPC. There are some security mechanism at play here without the vDefend firewall. So let me summarize very quickly what we've done. We've deployed an app using a public subnet that is visible from the outside world. But basically what I've done is that I've allocated 256 IP addresses, 256 public addresses in order to deploy this app, which is not very efficient because potentially those external IP addresses, those public addresses are a scarce resource, are an expensive resource. So I might want to limit the number of public addresses I'm using. So there is a way of explicitly designated a virtual machine, at least in fact, the VNIC of a virtual machine of being publicly addressable without exposing a whole subnet. So instead of reserving a whole block, we're going to assign an external IP address to a single VNIC of a virtual machine. Once we do that, there is a specific operation that I'm going to show you later. This virtual machine is assigned an external IP address that is dedicated to this virtual machine, and this virtual machine gain access to everywhere, to the outside world and also to other VPCs inside VCF. So I'm going to show you how this is done. I'm going to go back to my VPC, and that's not a realistic example, of course, but my app VM, which used to be private, I'm going to assign it an external IP and see that now, after I've done that, I can reach it from the outside world. So let's go back to our lab. I'm going to go to the VPC, and you see that there is a tab for external IPs. I'm clicking on it. Right now, there is no external IP, but I can assign an external IP. And when I click assign, well, here there is only one virtual machine. So there is only one option. It's the app VM. So I've assigned an external IP address to my app VM, and this app VM got 10.1.0.2. It's a public address. Note that it kept its internal IP address. So this virtual machine now has two IP addresses. The internal IP address is still used inside the VPC and the VCF environment, but from the outside world, I can connect to it using the public IP address. And the way this is done is that NSX in the background on your VPC has automatically plumbed the appropriate NAT translation and the appropriate routes so that the external IP address is converted automatically to the internal IP address, if we can call it this way, when entering the VPC. So now I'm going to go back to my web browser and attempt to connect to this public IP address 10.1.0.2. And of course, it's going to work. And you can see that the backend server only knows its internal IP address. The whole NAT stuff has been done behind the scene. It's just made by the VPC infrastructure. The virtual machine is not involved in that. Okay, so let me recap the whole demo, and I have a reason to do that. We have created a VPC. We have created two virtual networks called subnets. We've configured routing between them. Actually, we didn't configure it. It was automatically configured for us. My point is that there is a logical router automatically instantiated for you for providing connectivity between those two web and app subnets. I've made one of those two subnets externally accessible. And finally, I've shown you how you can easily make an exception for a private VM so that it gets an external IP address and that automatically configures NAT for you. The point I'm making here is that we've done that by just clicking in the vCenter UI and without ever having to really use any kind of advanced networking construct. And what I would like you to think about is think what it would have meant to do this with a traditional VLAN MAC network. All those operations that have been done behind the scenes by NSX, you would have to do them in your physical infrastructure, most likely by opening a ticket to the network team. And it would have potentially take weeks. So we've done everything in a completely autonomous fashion as an application developer using vCenter and without interaction with the network team. That can take seconds instead of weeks. Basically, that's the benefit of this feature. So now let's step back and explain a little bit how this is working in your VCF environment. So what you see is that, oh, okay, my web subnet can talk to my app subnet. And I showed you earlier on that there was a router that was instantiated automatically. But basically, how is all this implemented in your VCF infrastructure? Well, because this is VCF, your virtual machine are running on ESX hosts, of course. And behind the scenes, when VCF installs, is deployed, it's configuring automatically the NSX infrastructure. So NSX is part of VCF. It has always been part of VCF, actually. And it is automatically configured for you. You only have to provide a network for what we call the tunnel endpoints. It's basically, if you're familiar with ESX, a kind of VM kernel interface that is being used by NSX to provide interconnection. So this V-networking, this network that you need to provide is exactly the same kind of configuration that you will need for vSAN or vMotion. You just need one network with IP address for the VM kernel interfaces. They're called TEP in the context of NSX. But once you've done that, all that I'm showing you here is automatically configured by the VCF installer. So automatically for you, NSX is going to deploy those logical routers on the different ESX hosts. In the case of a VPC, it's called a VPC gateway. And if my web VM wants to talk to my app VM, the traffic is going to be routed internally directly on the ESX host by this logical router. Now, think about the next step here. I'm trying to reach the app subnet from the web subnet. Both those subnets are virtual. They don't exist in the physical infrastructure. So I cannot just send the traffic out and expect the physical infrastructure to route this traffic between ESX1 and ESX2. So what NSX is doing is between the tunnel endpoint I mentioned earlier on, it's creating tunnels, of course, and it's going to tunnel the traffic in the virtual app subnet. It's a virtual network, an overlay network. It's going to tunnel it to the right destination on ESX2. And all this is done automatically for you. If the app VM was to move to another ESX host, the tunnel will automatically move with it. So the benefits of this model is that you have a network that is entirely decoupled from the physical infrastructure. There is no silo. You can move your virtual machine anywhere, and you can instantiate as many network as you want without having to configure anything in your physical infrastructure. So we've seen how networking works inside VCF with NSX. Now, how to communicate to the outside world? Remember, I said the web subnet and app subnet are entirely virtual. They don't exist in the physical infrastructure. So the physical infrastructure doesn't know how to reach it. Well, we're offering two options based on two different kind of transit gateways. So the transit gateway is another logical router that is automatically deployed for you when you install VCF. And its role is twofold. It's going to interconnect the different VPCs together. So I have one VPC gateway. This is a VPC gateway on each VPC, and they're all connected to the transit gateway. So that will allow you to have inter-VPC communication. And at the same time, this transit gateway is connected to the physical infrastructure. There is some additional complexity here, but at high level, this is how this works. Oh, let's do a little recap here. You remember I was mentioning that I was going to explain the name private transit gateway later on. Well, you can clearly see that the transit gateway is here above the whole VCF infrastructure. So the private transit gateway subnet is something that has a scope and the reachability of the whole VCF infrastructure. It's below the transit gateway. That's why it's called private transit gateway subnet. The transit gateway is available in two form factors. And now we're talking about the way VPC is, as a feature, is installed in VCF. The traditional way, and don't worry too much about this slide, it's preloaded. I'm not going to detail this. The traditional way is to instantiate this transit gateway on an appliance that is called an edge VM. The Edge VM is a kind of service appliance that is specific to NSX, and it can host several gateways. It also hosts what we call a tier 0 gateway, which is responsible for peering via BGP to the physical infrastructure and advertise the internal logical network to the outside world. So I was telling you earlier on, how does the physical infrastructure know how to reach the virtual network? They are advertised by a standard routing protocol called BGP. This is a very networking involved model. It can be deployed directly from vCenter 2 in VCF9, but I'm not going to focus on that. There is a second option called the distributed transit gateway. And this one is very simple, and that's the one I'm really excited to show you. Basically, in that case, there is no edge, there is no BGP. Your transit gateway is a logical gateway that is instantiated on each and every ESX host. And the only requirement that we're introducing is that all your ESX hosts have to be attached to a common VLAN with a subnet. So this is a strong requirement, by the way, but assuming that you have a modern physical fabric, like a fabric capable of running VXLAN or VXLAN with a VPN, this is something that can be achieved at scale and a reliable way. So as soon as you have this, we'll be able to have communication between our virtual networks and the physical networks directly through these VLANs. And the external IP blocks, the blocks that needs to be negotiated with the physical infrastructure, they're simply going to be the IP addresses that are available on this VLAN. So if you have a virtual machine that has a public IP address, it's going to be taken from this block, and from the physical infrastructure, it will look as if this virtual machine was directly attached on this VLAN. So there is no need to use BGP and advertise subnets because, again, from the perspective of the physical infrastructure, this subnet is directly attached to this port. So there is very limited interaction between VCF and the physical infrastructure in terms of routing. It's very simple to configure. And actually, I'm going to show you as a third demo how this is made. So I'm assuming again that I have a VLAN, that's VLAN 10, to which all my ESX hosts are attached. And on this VLAN 10, there is a default gateway, 10.1.0.1. That's a physical router. And I have a large subnet that is going to be used as my external IP block, 10.100/16. As soon as we want to reach an address in 10.100/16, the physical router knows that it needs to send it on VLAN 10, and VCF will take care of the rest. So let's see how this is done straight from vCenter. So now I'm showing you vCenter just after you have installed VCF9. So assume that we've installed a VCF9. We're going into the network connectivity for vCenter. And you see that you have new options. You have the VPC, VPC subnet, and you have this network connectivity option. This is what will help you configure connectivity for your VCF environment. So I'm going to click network connectivity. And I'm given the option of those two, well, centralized or distributed transit gateway, the one that I was mentioning earlier on, and I'm going to select distributed connectivity. I click next. This is basically a summary of the prerequisite. And I'm going to enter the information that I showed you earlier on. The VLAN that is common to my hosts is VLAN 10. The default gateway is 10.101/16. Now, here I'm going to specify the external IP block, which is basically the subnet that exists on this VLAN. And finally, I'm going to provide the VCF private transit gateway IP block. Remember, the block from which we will allocate IP addresses for our private transit gateway subnets. So that's all I need to configure. I click deploy, and that's it. So let me recap what we've just done. VCF9 was installed, right? And it has configured the tabs on your ESX host. I have one VLAN on my physical infrastructure. That's the only thing I need to ask for the network from the network team. I configure this, and that's it. I have the VPC environment ready to consume. In fact, this is the first part of the demo I showed you earlier on. The two different demos, the two first demos that I showed were recorded just after this screen. I directly went and created a VPC, my app and web subnet, etc., etc. So this is already operational with just that. Let me try to reframe, if you want, the benefits of the VPC model, comparing it with using vSphere alone and VLANs in the physical infrastructure, and even NSX without VPC. So let's start with the vSphere model. In the vSphere model, if I want to deploy a new application, I'm going to basically open a ticket to the network admin and ask them for a certain subnet with capacity for certain IP addresses. I'm going to say, oh, I need one public subnet. I need two private subnet. I need a routing between them. I mean, the list goes on and on. That's a ticket, basically. I open this ticket. I send it to the network team. The network team comes back with everything configured in the physical infrastructure. Then I can create a DVPG with the appropriate VLAN and attach my VM, and I'm done. So on one hand, it's very simple because the only thing I need to do is create a ticket and I don't need to know networking at all. On the other hand, I'm completely dependent on another team, and we had literally feedback from customers who say that it can take weeks to deploy a new app using this model. So the NSX model allows you to get rid of the interaction with the physical network by virtualizing everything. So I'm an application developer. I want to deploy a new application. I can potentially do everything, all the networking part, directly from NSX without having to make any change in the physical infrastructure. Remember, I showed you earlier on that we can instantiate how many networks we want in NSX without making any change in the physical infrastructure. So this is all nice. And with that, with proper automation, you can deploy your application in minutes or seconds, just like I did with my VPC model. However, there's a catch. The catch is that this NSX configuration require networking expertise. So if you're just an application owner with little network knowledge, it's a big step to have to understand all the configuration in NSX and well, how to create a virtual router, advertise your new subnet via BGP to the physical infrastructure, etc., etc. So it's a little bit as if you were again dependent on someone else in order to deploy your application. Maybe an expert in the VI admin team, a networking expert in the VI admin team. So potentially there is this kind of ticket system that is creeping back into the picture. And that's where the beauty of the VPC model appears. Basically, I'm an application developer. The only thing I need to do is the first demo. Basically, I create my VPC and I create my subnet and I attach my VMs. And you've seen the clicks that were involved. It's very basic. I don't need any networking knowledge. Even better, the pre-configuration that is done, we've seen it also. It's not that complex, but not only is it easy, it's also something that you only need to do once in the beginning at the moment when you deploy VCF. You deploy VCF, you enable VPC. If you don't have the network knowledge to do this, even if it's super simple, you have an expert that helps you at that time, and then you're done. You don't have to go back to it, and the application developer can still consume networking without you in the future. That's what makes the VI admin independent, the application developer independent from the networking team. So I'm almost done. I would like to bust a myth about VCF. So VCF now is the main product from VMware, and many customers are discovering that they're getting NSX and virtual networking because they're getting VCF. They didn't have VCF before. And there is this myth that you have to migrate your existing workload so that they use virtual networking. And of course, this is absolutely not the case. Virtual networking and VLAN-backed DVPGs coexist. In fact, when you onboard VCF over your existing infrastructure, your workloads that are attached to port groups are simply unchanged. So you don't have to use NSX or VPC. However, the good thing also that most people don't realize is that you don't have to use one or the other. You can have workloads that are VLAN and DVPG attached and use VPCs on the same VCF infrastructure. And even better, your VLAN attached and subnet attached workload can communicate with each other through the physical infrastructure. So start with your existing environment and change, and just deploy new workloads with VPC on the side. And you've seen, hopefully, in this presentation that it's very easy to do and very easy to consume virtual networking. So that's my last slide as a wrap up. Basically, I hope you have seen that VPC makes virtual networking straightforward in VCF, straight from vCenter for somebody who doesn't have any networking expertise. Some benefits of virtual networking: break down silos. Again, your virtual machines are not constrained to the network that exists in the physical infrastructure. Those virtual networks can be instantiated automatically without any dependency. So no silos, no need to configure anything in the physical infrastructure. All those virtual resources are elastic. There is no appliance that is being deployed. All this can be instantiated on demand via API and automated. And finally, you see that you can deploy your new apps in a matter of seconds instead of potentially weeks because of a ticket system. So please try this at home. Use VPCs. Don't need to migrate anything that you have in your existing environment. Just click Add VPC and have fun. That's all. Thank you very much for attending. Any question that we need to address? I don't think there was any. So that wraps up. Thank you.